All right, good morning, everyone. Can everyone hear me all right? Can everyone see me all right? I'm gonna give you a quick minute to give me a thumbs up, yes or down. Yes, I see the word yes. Woo, awesome, okay. So welcome to our fourth installment of our live science series here at Chabot Space and Science Center. We are super stoked to be back with you today. And you may notice that I'm wearing my mask today, and that's because I actually have some assistants that are going to be helping me out. These are some of our Skyline GEs. They're going to be popping in on screen and actually helping me do our live science show today for you all. So we're going to have some teens demonstrating science live. It's going to be awesome. So I'm going to introduce them. We have Julie. She's one of our Skyline GEs. Everyone say hi, Julie. Nice. And we also have Jada. Everyone say hi, Jada. She's going to be helping out as well. So they're going to be lending me a helping hand with our demos. Now, many of you may know that right now, during this time, Chabot Space and Science Center is currently working on our reopening plan. So we are not open to the general public, but we will be opening eventually, and we're planning some really fun things for you all. We are also working very hard to provide free and available and engaging STEM programming, such as our live science series like this. So we are going to be doing a live science demonstration. What does that mean? It means we're going to be doing it live, and it's going to be showing some scientific concept or reaction or chemistry reaction. And we're going to need your help to help us figure out what's going on, why it's going on. We're going to need you to make some observations with your eyes and do some analysis and evaluation of what you're seeing to help us figure it out. So that's what we're going to need from you all today. But before we get started, Jada and Julie, if you want to come in real quick, we'll try to be distant. We need your help to make sure that we're going to do our science safely. So the first thing we have on today is our safety masks to help protect us, since we're going to be kind of close. But what else are we going to need to help protect us today? I will give you a hint. We are going to be working with fire. So what are some things or some tools that we might need to put on to help protect us? Go ahead and type it in the chat. What do you think we need? And we can hear from my coworkers who are off screen. What do we need? Eric?
Lab coats.
Lab coats? I have a lab coat. Luckily, we're not going to need those today too much, but I'll wear it just because we've got it.
Masks and gloves.
Masks, we got those. Gloves, we've got some gloves nearby. We're going to put those on when we're doing our demo.
Goggles.
And our goggles. I think these are mine.
David says shoes to run away with.
Shoes to run away. I think we all have shoes on, so that's good. Good suggestion.
And fire extinguisher.
And yes, always love that. Just in case of an emergency, we do always have our fire extinguisher on hand. We have not had to use it yet, but we always have to keep it around just in case. And this morning, before we began, I'm a trained scientist on how to do these demos, and I also helped train Julie and Jada on the right way to do this. So we're going to be helping them out, kind of walking them through what to do. But I'm here to make sure that we're doing this safely today. So that's kind of what you have to do before you get into your science, before you do these really fun but slightly dangerous demonstrations. It's always good to make sure you have your safety gear and your friends to help you get this done. Okay, so what we're going to do next is, who's helping me first? Julie's going to help me, and we'll see Jada soon. Julie's going to help me walk through this demonstration. So what we're going to do is we are going to kind of show you something, and I'm just going to tell you what we're doing, but I'm not going to tell you what it is or the science behind it. So I need your help to type in any observations that you're making while we do this. And if at any point you know what we're doing or you want to try to explain it, kind of like make a hypothesis or a prediction, you can type in the chat as well. All right? All right, so Julie and I are going to put on our safety goggles. We're also going to put on our gloves. And in front of me, you might be able to see we have these test tubes. So we have 5 different test tubes, and each one has something in it, a clear liquid, and it also has kind of a white consistent powder and some sticks. So we have 5 test tubes. And what we're gonna do is, Julie, I'm gonna ask you to burn one of these sticks with the lighter. And we're gonna see, can we light it? Yeah. I want to make an observation of what you notice about this stick that we light. And we might hold it up a little bit closer. All right, so we've got one stick.
It looks red.
We have an observation that it looks red. That's a really good observation.
Sort of fire.
Yeah. All right, so we're gonna do the next one. I'll hold it up just so you can see. This is our next one over. You can make an observation if this looks any similar or different from the first one. And what we're gonna do is we're gonna light this one on fire also. Who would have thought? And if you'd like, you can make a prediction. What do you think is gonna happen when we light this one on fire? All right, so we've got another one burning for you. You might have an observation of it. All righty, do you wanna hold it or light? All right, we're gonna do the next one. So just to show you, we have another test tube with a clear liquid and some sort of powder on the bottom. And we need your help making an observation of this one. Think in your head, do you think this is gonna be any different or the same as the last two? We've seen kind of a pink and kind of a red. What do you notice about this one? Any observations? Is this one different, same? Yellow, and it's kind of nice and bright. We're gonna put it up. I'll do this one. All right, now we're gonna do the next one. And just to keep it consistent, we'll show you another test tube, clear liquid, white powder. In my opinion, these all look exactly the same. I don't know about all of you, but somehow we're getting some different things. All right, this is our next one. I don't know if you can see this one very well. And then we're starting to see that yellow, which is interesting. All right, and then I'm gonna have Julie hold the last one for us. And you can take a look at the test tube before we do this one. Slightly different in my opinion. I don't know what you think. And then we're gonna light this last one on fire. And if you have a prediction of what color you think this one might be, go ahead and type it in. I'll wait for you whenever you're ready. No rush.
Green.
All right, ooh, we think maybe green. What do we think? What do we see?
Hey, Nicole.
Yeah. Nice. What are you noticing this time on our last one? Kind of green, and then it kind of getting that almost a white color, that yellow. Nice. All right, so we can take our goggles off. We're getting really sweaty in here. Very cool. So I'm liking our comments. We're seeing blue and green. We're seeing that kind of lightish yellow color. So can everyone thank Julie for me for helping out? That was awesome. Thank you, Julie. You can stay on if you want. So we just burned sticks from 5 different test tubes. And you got some comments saying thank you. 5 different test tubes. And they all look, well, I guess I can ask you, do you think that these test tubes look similar or different? And if you have a guess, why do you think they burned all those different colors? So we had the first one, which burned an orangey red. The second one, which was more of like a pink. We had the third one, which was yellow. Fourth one, which was kind of clearish blue. And then the last one, which was green. So does anyone out there have a guess? Why, even though these things looked the same before, why do you think they were burning different colored fire? I'm gonna give you like 30 seconds. I'll just wait. If anyone wants to try to guess what was happening, why did we make different color fire, even though it all looked the same in the beginning? All right, we have a guess of different liquids. We have a guess of different chemicals. What else might we be seeing? And we have two streams going. We have a stream on Zoom and a stream on Facebook. So we're going to see, yes.
I have different elements and they are salts. All different compounds.
Nice. Someone on Facebook said they're different elements and they're different salts. They're all different compounds. You're pretty much on it. That's pretty right. I'm going to just see anyone else have any other
Different kinds of fuel.
Oh,
different kinds of fuel. Yeah. What else?
somebody says there are different amounts of powder.
Different powders.
Good observation. There are different amounts of powder, like this one versus that one, for example.
Someone
Does
saying
that
they
have any-
burn at different temperatures.
Do you think that they burn at different temperatures? That's a good guess. Is the wood the same? Yes, these are all the same types of sticks. That's a really good question to ask though, because this could be different. All right, any other good last minute guesses before we run through it again and I explain what's going on? All right, you're all on the right track. So it all has to do with the fact that these little powders at the bottom, this white stuff, is all made up of different materials. And what they're made of are different things called element salts. So one of you said different chemicals, different compounds, and you're exactly right. So we've taken different elements, and you can buy them from special lab stores in a salt form. And in a salt form, they're kind of a powder, like a table salt. And we've put them in a liquid that is flammable. And when we burn them, we see those different colors. So I'm gonna ask Jada to come back up and help me, and we're gonna burn through our different sticks again. And while we do this, I'll explain some of the science of what's happening. So this time the order doesn't really matter. So we're just gonna go in whatever order we feel. So we're gonna burn our first one. There we go. All right, so the first one that we burned, we're seeing this nice, beautiful red color. And what's happening is that we have an element in this test tube, and this element is called lithium. Now, what happens when we burn lithium, kind of a pinkish red, is that around these different elements, like lithium, they each have their own individual compounds. They have their own individual number of protons, neutrons, and electrons. And electrons circle the outside of the atoms of these different elements. And what happens when we add energy to them with a flame is those electrons get excited and they jump. They jump from where they originally are to a higher energy level because they're excited. And then eventually, just like us, if we were to jump up, we have to fall back down. And when they fall back down to their state of rest, all of that energy that they have is released, and it's released in the form of light. So the electrons that are around those lithium ions are getting excited, and they're releasing light, and they're releasing this red light. So let's burn the next one. Do you want me to burn it? All right, so Jada's gonna hold this one. This is a different element. We're gonna burn it. And you can see this one also has kind of a red color. The same thing is happening. The electrons around the element salts that we're burning are exciting and then de-exciting, and they're releasing light in the form of a photon. And that one was still red. So let's burn a different one that's a little different color, and I'll talk about why they're different colors. So which one do you want to do? My favorite. Oh, that second one, by the way, this one was called Strontium. So Strontium was the second one, that kind of orangish, reddish pink. So lithium and strontium are very similar. They're very similar in terms of the color that they burn. But now we're gonna do this one, which is my favorite. And then you can see what's that different color. This is more of our bluish green. And that one is a copper chloride. So that one has copper in it. If you were to take a copper pipe and put it in a fire, it would actually turn your fire green. However, you should not do that because it is dangerous. And the fumes that it releases can be dangerous for you to breathe. But because we're seeing that different color, that means it's a different element. And copper is a different element, so it burns that different color. Yeah.
David wants to know, are any of these elements in lava?
Are any of these elements in lava? I don't actually know. That's a really good question. That's a good, we're gonna Google that one. Now this is more of our yellowy orange color. I like this one a lot. That nice, beautiful glow. And this one is something that you can find actually lying around at home. That is sodium. So this is a sodium chloride. If you've heard sodium chloride before, that's actually the chemical name for salt. So if you were to take salt and burn it, but you have to add like a flammable fuel like methanol, then salt burns that nice yellow color. But that one is sodium. Yes, Natalie.
Somebody asked if strontium is radioactive. I hope not.
Is strontium radioactive? We had a question. Not that I know of. There are certain elements that are radioactive, which means they are like decaying and giving off, I think, energy or ions. But most of these are stable elements that I know of.
Strontium 90 is a radioactive isotope.
Yes, so certain. Nice. So strontium 90 is a radioactive isotope, but strontium in the form that we get it is like a regular non-radioactive chemical. But that's the craziest thing about chemistry and elements is they come in different forms. But what we're doing when we're doing this is we're exciting all of the electrons in these elements. And I think we have one more. Did we do this one? All right, we had one more we hadn't walked back through. So we're adding energy in the form of fire. And when we add that heat, the electrons in those elements, you can barely see this one, the electrons in those elements are getting excited. They're jumping up to a higher energy level. They're falling back down. They're releasing that energy in the form of light. And what you see here is the actual stick itself burning. And that's because most fire that we see is made burning organic materials like sticks. And when you burn sticks or organic materials that have carbon or oxygen in them, you typically get that yellowy orange color. That's why we don't usually see green fires at like campsites, because logs aren't made of copper. And copper wouldn't be a very efficient fuel to use to make a campfire.
Well, I got some crazy questions.
All right, we have some questions. While we answer them, Jada, would you feel comfortable taking one stick from each and burning them all together? Okay, I'm gonna let you set that up.
Okay.
We're gonna answer questions, but while we do that, Jada's gonna try to get another one ready.
It's from Rihanna.
Okay, Rihanna has a question.
Why do different elements burn different colors?
Oh yeah.
They are all working the same way, aren't they? And then just the electrons jumping up and something else.
Okay, so we're gonna get a little into the chemistry. So I forgot to answer the question, why are they burning different colors? So because each atom of each element is made up of a different number of electrons and protons, that's what makes them different on their molecular level. But because they're different on their molecular level, that means the amount of electrons in their outermost ring is different. There might be 3, there might be 4, they might be arranged differently as well. So the jump that they make when they go from their state of rest to their excited state, this jump that they make is going to be a different size for the different elements that we're burning. If the jump is really big, it might create a different color flame, because as they're jumping back down, the amount of energy that they're releasing might be bigger or greater than if an electron made a small jump. And the reason that changes the colors is because as that light is released, the wavelength of that photon, the size of the wavelength of light, changes the color that we see. There's a difference between short wavelength light and long wavelength light, and that's something as simple as the color. So I believe that short wavelength lights, which are higher energy, burn colors like blue, greens, and purples, and longer wavelength lights that are lower energy burn colors like yellow, orange, and red. So it all has to do with the movement of the electrons and the wavelength of light that they're giving off when they release that energy. It's a little complex, and I don't have as many diagrams today as I wish I did, but it all has to do with the size of this jump and the light, the wavelength of light given off. So Jada, before we move on to our next question, we're gonna light all 5 of them on fire at the same time because we can. All right, and then we'll have Julie do it too. All right, so this should be our rainbow stick. If we're lucky. It does look really cool in person. Unfortunately, it's a little hard to pick up on the camera, but you can see we've got more of our blue flame on this side, more of our red flame on that side, and then now the sticks are starting to burn, giving us that bright yellow. Nice, I'm gonna throw it in there. Super cool. And can everyone say thank you to Jada for helping us out, being a wonderful helper? And then Julie, do you want to do one too? Or you can pick a color combo if you want to do a select too.
What is happening with elements decay? Definitely beyond me.
Someone asked, what is happening when elements decay? To be quite honest, I knew at one point and I don't know right now. And I don't want to give you the wrong answer. So I'm not going to answer that one. You've stumped me. And I encourage you to look it up online. It does have to do with like the ions, and it's releasing ions, and it can actually give off energy. The one thing I do know about it is that that's one of the ways that they power rovers on Mars, is they use radioactive decay as the energy source, because as an element decays or ions decay, they can create energy. So rather than like a solar panel, which is iffy on how it gets energy, if there's no sun, you have no power, they can use radioactive decay to power rovers. But I don't know the true science of that one. I just know that's one of the ways they power rovers, like Curiosity. So you stumped me. I would look that one up.
What's the 4th stick?
The 4th stick, this one? This is potassium. That burned, it's of like a purplish blue, but it almost looked invisible just because it's really low color. And we're gonna burn this combo that Julie has put together, and then we're gonna take a question. All right, so this one is copper, potassium, sodium, strontium, and lithium.
A white piece of paper behind it, if that would be easier to see the plan.
All right. I think the dark. Yeah. Oh, that was good. All right, so that one has copper. That's giving us that greenish blue. We've got potassium, which is that purplish, and then we've got the 2 reds, lithium and strontium. And then now it's the sticks going in. Bye. Very cool. So we can kind of change the color combination that we want to pick. All right. Does anyone have any more questions? Because I do have a why is this important? Oh, Natalie has one and Eric has one.
So they're wondering if it would be safe if you mix the actual chemicals together and then lit it, and if you would get the same effect as lighting them with the different sticks. Oh, that's a nice question.
That is a good question. Someone asked if we would get the same effect if we were to mix the liquid from 2 test tubes together and then light it versus burning 2 separate sticks. And I don't have an extra test tube here with me, otherwise I would have tried it. But my assumption is that you would get a mix of both, really. I don't know how different it would be. We could grab a test tube. Does one of you want to go into the bio lab? The lights are to the left. You can grab a test tube. It's like in the cupboards. Maybe you can find one. I sent Julie to see if she can find one, but we don't know. We'll see.
So now, what is the difference between ions, electrons, neutrons, and protons?
Okay, this is a very poor drawing of an atom. But in the center of an atom, you have protons and neutrons. And protons have a positive charge, and neutrons have a neutral charge. So say you have 3 protons and 3 neutrons in the middle of your atom. I can't think of what element that would be. Helium? Boron. It might be boron. So anyways, say you have 3 protons, which are positive charge, and 3 neutrons, which are 0 charge in the middle, then mostly that element will have 3 electrons, which have a negative charge floating around it. So if you have 3 protons and 3 electrons, that means, and 3 neutrons, which the electrons circle around the outside, the protons and neutrons are in the middle. If you have equal amounts, then your element is like in its state of rest. It's good. It's not doing anything out of the ordinary. But if you take away electrons, or if you add elements to other elements, like if you had potassium combined with sodium, that would change the number of electrons and protons that it would change the number of electrons that they have. So basically, one is positive, one is neutral, one is negative. And each element has a different number, and that's what determines what element they are. And elements are like the building blocks of life. So they kind of make up everything around us. I'm not like a true chemist. I do like chemistry, but I only have the basic understanding of it. So good question. The internet will help you explore more. We have a test tube. All right, we're gonna try what someone asked, which is to burn 2 of them together, but the liquid. I'm gonna do sodium, which is like a yellow color, and we'll do lithium, which is like a red. So see if we can get more of like an orange. All right, so sodium and lithium, we've mixed the liquid together. And I have to let this soak for like at least a minute. It might not work if we don't. Do we have any more questions while we let this soak?
Not on my side.
All right. Oh, while I do this, I'll tell you, why is this important? So if you've ever seen, or have you ever seen colored fire before in real life? Think of a time that you may have seen colorful explosions, maybe up in the sky,
Yes.
maybe sometime in July, in the beginning.
Fireworks.
Ah, fireworks. How many of you have seen fireworks before?
Oh, and a comet?
So in fireworks, the colors that we see are actually thanks to these element salts. To make a firework, they often pack gunpowder with element salts. And when they burn or they explode, the element salt makes the different color of the different fireworks that you see. So this is one of the ways that they actually make colored fireworks. Pretty exciting. It all has to do with those different elements that they're packing in there. All right, does one of you want to come burn this with me?
When you get shocked, are you just giving or taking electrons?
I don't know. Someone asked if you get shocked, are you giving or taking electrons? And I don't know. I'm assuming you're taking them, but I don't know. We're getting into some deep chemistry here. All right, let's see. We mixed lithium, which is red, and sodium, which is yellow. And it's kind of like an orangey orange. But that's what happens when you only soak them for like a minute. All right, so when you mix them, it seems like they just kind of mesh the two colors together. Do you want to burn any more? Because we have the rest of these still. And then Jada, do you want to come burn some? All right, we're gonna finish burning the rest of these just for fun. Jada, if you want, you can come over here and do it. Yeah, while we finish burning these, I just wanted to say thank you to everyone that has tuned in. Thank you to Julie and to Jada. These are two of our GEs, which is our teen volunteers. They go to Skyline. They're our special, it's a new program that we're doing with our Skyline GEs, and they've been helping us out all summer, and they're awesome. And we're gonna burn some of these for y'all. Woo!
Oh wow, that's cool. Look at that. It's green and red.
Ooh, that's a good one. But yeah, while we are waiting for our grand reopening plan, we do want to ask that if you are available and willing to make a donation to help support our free programming, we do have a link in our bio, both on Facebook and in Zoom. You can click the link to donate to help support programming like this, as well as our Skyline GE program. And you can join us for our other free events. We do have live telescope viewings, virtual, on Friday and Saturday nights. This one's running low. So feel free to join us on Facebook for our other free events that we host during this time. And yeah, we'd love your support in any way that you can help us. And we just want to thank you all for joining, and we will see you next week. We will be doing this again next week at 11 a.m. with a different demonstration each week. So always tune in, have fun.
Don't forget our SETI talk tomorrow night.
We have a talk with SETI, which is the Search for Extraterrestrial Intelligence, tomorrow night, posted on Facebook?
Yeah.
Facebook Live, so join us for that. And yeah, we'll see you next week. Stay safe, wear your masks, stay curious, and we'll see you then.
Thank you.
Sorry.
Sorry, I was reading the comments because